All right, all right, all right. I told you we'd come right back here for day 2. Same idea. Okay, we're going to find systems by graphing. I'll zoom in so you can read this, and then I'll put it back to where it was because I can't write when it zooms. So we've got a roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $1,040. And the second purchase at the same prices buys 8 bundles for $256. Find the price per bundle of shingles and the price per roll of roofing paper. So pause, zoom in if you have to, write down the important information. What you're going to have to do here is you're going to have to write 2 equations. Okay, so I've got 30 bundles of shingles, 4 rolls of roofing paper. First things first, set up your variables. Okay, I've got S is S for my shingle cost, R for my paper cost. So I've got 30 bundles of shingles, 4 rolls of paper. So I've got 30 shingles, 4 rolls of paper is 1040. Okay, read the sentence, write the equation. 2, in a second purchase, the contractor buys 8 bundles of shingles for $256. So I've got 8 bundles of shingles. So that's 8 shingles, $256. Find the price per bundle of shingles and roll of roofing paper. So now, it didn't buy any of that the second time. So, some of you are going, I can do this, it's pretty easy, with some algebraic methods. Okay, I'm hoping some of you can see some algebra here. Like, if I bought 8 of these for $256, could you just divide to find how much that is? Yeah. And if you know how much shingles are, you could plug it in up here to find how much shingles are, and then you could work backwards to find the rolls of paper. Yeah, absolutely. That would be beautiful, pure genius. I would agree with that 100% and commend you upon your intelligent work. As a matter of fact, why are we going to make this harder than it needs to be? Okay? You don't need to make things hard, do you? Do you need to make things hard? I don't like to make things hard. All right. Let's do it. Be smart, right? If there's 8 shingles for $256, somebody get a calculator. What's a $256 divided by 8? So 32. So I know one set of shingles is $32. It's got to be $32, right? I'm dividing by 8. Well, if that's $32, how much did I spend up here? Well, calculator people, if one shingles is 32, what's 30 times 32? 30 times 30 is 900, 960? So I spent $960 on shingles on this first purchase. How much was the roofing paper? Well, we can just subtract. 960, 1040, that's 80. Divide. Roofing paper's $20. So they really want you to make some complicated graph out of this problem? Be smart. Why? Why do it? All right? All right, you want to graph it anyway? Fine. I don't care. We know the answer. Shingles, roofing paper. Graph. So, how would I do this graphically? Well, I got R's and S's. Well, you just pick variables, make one of them X's and one of them Y's, okay? So I want to rethink this as 30x plus 4y equals 10. 40 and 8x equals 256. Why did I do that? I don't know, just because I matched my x's were first and my y's were second. That's it. No particular reason. So I'm going to erase this and give myself a little bit more room. Generally, you know, some of those other problems we talked about, independent and dependent variables, there's no real independent dependent here. One doesn't depend on the other. The final price depends on how many of either of them, but there's no independent dependent here to make me pick one as x and one as y. Okay, I'm just picking both of them. So now I need a graph. Well, get y by itself. Subtract, I'm going to bring this work over here so I kind of stay out of the way here. Subtract 30x. Divide by 4. Now again, I've got 30 over 4. Divide by 4 there, I'm going to get 250, 258. I need a calculator on that one. Let me double check that real quick. But let's talk about that 30 over 4. We've talked about this before. I want to leave that improper, but I don't want to do a fraction. I don't want to do a decimal. Definitely don't want to do a decimal. 260. What's closer? I knew 258 just didn't sound right. 260. I definitely don't want a decimal here. I want a fraction. I don't want those big numbers if I can. So 2 goes into both of those. So minus 15 over 2 plus 260 equals y. Here's the problem with the graph. That's an ugly graph, boys and girls. I got to make a big, huge graph. Something's going to go up to 260 and then down 15 right 2. Okay? So it's going to be an ugly graph. I'm not lying to you, but hey, you guys wanted to do this. All right? So I've got y equals, there's one equation right there. Here, divide x equals 32. There's my other equation. So now I need to graph this. Before we go any further, what kind of graph is that? Very special one. Think back. Okay, we talked about those. I know it's been a while, so I'll give you some hints. Is this vertical or horizontal? Is it horizontal or is it vertical? X equal a number. Well, remember, x equal a number. This is my y-axis. This is my x-axis. So if x equals a number, I would go out here to 32, and I would have x equals 32. It is a vertical line. If you forgot all of that, write that in your notes and remind yourself. So that's a vertical line out here at 32. So now I've got a y-intercept of 260. Holy smokes. I'm going to fix this. What should I count by 20s? All right. 20, 40, 60, 80, 100. 20, 40, 60, 80, 200. 260 is my y-intercept. Down 15, right 2. So let's count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8, 32. I got a vertical line out here at 32. This is a mess. Who wanted to graph this? I know one of you said that, well, can't you just do a graphing? I know one of you said that. Goodness gracious. I gotta go down 15, right 2. But remember, I simplified this. So I can go down 30, right 4. It'll get me there a little faster. And these are by 10s anyway. So 10, 20, 30. And these are by 2s, right 4. 30, right 4. 10, 20, 30, right 4. This is an ugly mess. Who did this? Down 30, right 4. Holy smokes. This is going to be ugly, I'm just telling you. 30, is this 10s? No, this is 20s. Oh, goodness. See, I get 30s right here. That makes a big difference. I'm just kind of eyeballing this. You got graphs on those computers? Oh, what do you know? It hits right out here. We already figured out the answer, right? So we know what location that is. We plug it back in here to work it out. That's an ugly graph. When I saw that, oh boy, I would like the algebra. It's a good thing Starting next week, we're going to be talking about algebraic ways to solve these problems. All right? So if you can figure out the algebraic, go for it. If you do it graphically, do it graphically. I'm done talking. Have a good weekend. Adios, boys and girls.